Hello everyone, I am Diya Kulkarni and today my teammate Kaustubh and I will be showing you the working of a function generator. So basically this is a 1 MHz function generator and the model number is FG1MD. So moving straight to the point, this is basically the display where all the frequencies will be displayed as and when we vary it, and this is the frequency range as it ranges from 0.1 to the maximum value, that is 1 megahertz. So in order to select a particular frequency, we have to select one of the buttons that are mentioned. For example, I have selected a 10 hertz range, and as you can see the output is displayed on the screen. And now we select 1 kilohertz frequency and it is displayed on the screen likewise. So these are the two probes, which are the coarse and fine frequency probes. This is the coarse probe which shows large differences in the frequencies, and as I move it you can see that we have large differences in the frequencies that we have selected. For example, as we selected 1 kilohertz, we can see the large difference that we are getting in the frequency range. And this is the fine probe. Fine probe is basically to have smaller differences in the frequencies, that is in decimal points. So as we move the frequency probe, the fine probe, we would see that there are very small differences in the decimal points of the frequency that we have selected. As we select 1 megahertz frequency and we move the coarse probe, we would see a very large difference, and in fine probe we would see a very small difference of decimals in the frequency range. And this is displayed on the screen likewise. So as we select the minimum frequency range and as we move the coarse probe, we would notice that there won't be any change in the frequency as it is selected to the minimum value. And if we select any random value, the output would not be the same and we will be able to have a varied range of the frequency that we want. So now we would talk about this frequency button over here. This frequency button is basically used to show frequency as well as the voltage from peak to peak value. And as we select the button, we would see the voltage that we want in the display screen. And as we select the voltage value and as we move on to the level fine probe, we would have a range of the voltages that we want from peak to peak value. So now as I'm moving the probe of the level fine, we would see that we have different voltages accordingly. You can see the voltage range from 0.5, 0.3, 0.2 and accordingly. And as we deselect the button, we would notice that this is now used for frequency. For that, we now need to press any of the frequency range buttons, and now as we have selected 1 kilohertz button, we would see that we get the frequency likewise. Now moving on, we would see this particular area over here, that is the function where we would see sine wave, square wave and triangular wave on the digital oscilloscope that we would connect it to in the further part of the video. So now we would talk about the different probes in this particular function generator. So this is basically the TTL probe. The TTL output will produce a 5 volt square wave with a frequency equivalent to the value that you programmed into the function generator, and this is the function probe, which is basically used to generate the signals that you would further connect it to the digital oscilloscope. So here I will connect the probe with the digital oscilloscope that is placed right next to the function generator. Now we are connecting the probe from the function generator to the digital oscilloscope that is present over there in order to generate the signals.
For visualizing the waveform, we need a DSO. That's why we have connected the probe from function generator to DSO to visualize the waveform. We have applied a frequency here, that waveform we have to visualize on DSO. Here we can see a sinusoidal waveform that we have applied. Here you can see three types of waveform that we can apply to our function generator: sine, square and triangular waveform. And we can change waveform to triangular by pressing now. And so square by pressing the square now. We can change frequency through the function generator. Frequency changing. Our waveform will change according to the frequency we have applied. By decreasing the frequency, we can see increase in the time period for the graph for positive and negative half cycle. As we continue decreasing the frequency, the cycle length increases and our amplitude remains constant. You can also see our frequency applied and peak voltage on DSO. We will just auto set our DSO for getting proper waveform. Now we will turn on our symmetry button on function generator for getting a symmetrical waveform of the particular frequency we have applied. By pressing the knob, we will get a symmetrical waveform. We again have to auto adjust on our DSO. Now we can change the duty cycle of our waveform, and T on and T off state of our waveform, by which the positive and negative part of the positive and negative half cycle will change of our waveform. By increasing duty cycle, positive state will increase, and by decreasing, negative state will increase. We can also check it for sine waveform by increasing duty cycle also. We are getting our proper waveform. Now we have our attenuation knobs for changing the shape of the graph or dividing the shape of the graph by 20 or 40. We are divided by 20 and now by 40. So to get a small graph, in case of graph is very large, we will again press them and the attenuation will cancel. We will get our original waveform. And now we have our DC offset button for adjusting the height of our waveform. Means we can shift our waveform up and down by increasing the DC offset. Our waveform will shift above, and by decreasing our DC offset it will go below. We can adjust it by changing our DC offset, and we can get our waveform at center. After getting it center, we will just auto set on our DSO, and this is our TTL now. We will check waveform for our TTL now. We will just auto set it. And we can get our waveform observed through our TTL now. So this was our experiment on function generator. Thanks.
Applications of a function generator. So basically, function generator are used in a wide range of applications, including electronic testing, circuit design, and education. Function generators are used to test the response of electronic circuits, and function generators are used to design and test electronic circuits. Also, function generators are used to teach students about electronics and waveforms. Now we'll be talking about arbitrary function generator, its use, its function, and the various knobs which are used in it. So, what is an arbitrary function generator? It is a versatile electronic test instrument used in laboratories and engineering settings. It creates various types of waveforms such as sine, square, triangle, side sawtooth, and more by generating signals based on user defined mathematical functions. So, next up, we'll talk about the function of arbitrary function generator or the applications as they are mentioned below. So, what is it basically? It is a type of electronic test instrument that can generate a wide variety of electrical waveforms. So, unlike traditional function generators, which are limited to producing sine, square, and triangular waves, AWGs can produce any waveform that can be defined mathematically. Its applications are wide ranged. It can be used as electronic design and testing, in biomedical research, and audio and music production, and many more. Now we talk about various knobs on arbitrary function generator and their significance. Mentioned below, the knobs are output level knob, offset knob, frequency knob, and waveform select knob. So what does output level knob do? This knob controls the amplitude of the output signal, determining the voltage swing of the waveform. Turning the knob clockwise increases the amplitude, allowing for a stronger output signal, while turning it counterclockwise decreases the amplitude. Offset knob is basically the knob that controls the DC offset of the output signal, shifting the waveform vertically along the voltage axis. Whereas the frequency knob basically controls the frequency of the output signal, determining the number of cycles per second of the waveform. Turning the knob clockwise increases the frequency, causing the waveform to oscillate faster. And last, waveform select knob is basically the knob that selects the type of waveform that AWG will generate. Common waveform options include sine, square, triangle, ramp, pulse, and noise. Some AWGs may offer more advanced waveforms or the ability to define custom waveforms using mathematical equations. Trigger mode knob. This knob selects the trigger mode, determining how the AWG starts and stops generating the waveform. Common trigger modes include free run, triggered, gate, burst, trigger level knob, etc. So what is trigger level knob? This knob controls the trigger level, determining the voltage threshold of the external trigger signal that will activate the AWG. Turning the knob clockwise increases the trigger level, requiring a higher voltage trigger signal. Next, modulation input. Some AWGs have a modulation input that allows for modulating the output signal using an external signal. This enables effects like frequency modulation and amplitude modulation. Sweep function. Some AWGs offer a sweep function which allows for automatically sweeping the frequency, amplitude, or offset of the output signal over a specified range. Menu system. Many AWGs have a menu system that allows for accessing more advanced settings and features such as waveform editing, wave storage, and parameter adjustments. Lastly, we talk about the offset knob. So this knob basically controls the DC offset of the output signal. The offset is the amount of voltage that is added to the waveform. Turning the knob clockwise increases the offset, and turning it counterclockwise decreases the offset. So this offset is typically measured in volts. So thank you for watching our video. Hope you found it informative, and like, share and subscribe. Thank you.